And welcome back. Now today we're going to be talking about how to write a library for any piece of hardware that you might have lying about. For example, I have this dual digit device here controlled by a shift register. Yeah, let's not get hung up about what it is. This mechanism for writing libraries can be used to control any piece of hardware. I'd like to give a big shout out to my sponsor PCBWay, PCB Prototype the Easy Way. Let's have a look at their new Superior A+ Advanced PCB. Here you can find all the details of what their advanced PCB service consists of, and there's a handy comparison table to see the benefits of the advanced PCB service. Scroll down to the PCB showcase and you can see some examples of what they can do for you. Just go to their easy online PCB instant quote page and select the advanced PCB option. Simple. If you have advanced requirements for your PCB, try PCBWay. Try them now. Yes, indeed. Now, of course, libraries are not just used to control hardware. They can be used to control code as well. For example, if you want a library to control string handling. Yeah, well, C++ and C has libraries for that. So it can be used for complex code functions that you don't want to write time and time again in your code. We'll write a library for it. But as Arduinites, I suspect most of our libraries will be useful for controlling hardware, like the piece you see on my workbench here. So let's use that as a very simple example. So without further ado, let's look at the sketch written on the Arduino IDE 2.0 and, well, why we even possibly might think about writing a library. So why would I need a library then to control something as simple as this 2-digit HC595 shift bit register controlled display? And the answer is, whilst I was writing the sketch you can now see on screen there, that's using the Arduino IDE 2.0.0 by the way, it became pretty obvious that some of the code is very repetitive and laborious, and you think surely there must be a better way to output serial data which that device can understand, and just goes, yeah, great, that's fine. So we're not going to go through the actual code, what it does. If you really want to know what that code does, watch the previous video because that explains how we can control that device. But in essence, we're sending out serial data, that is, pulses on a line in a certain format that turns into digits on that 7-segment display. Great. Okay. So you can already see up the front there that there's some pins defined. We always need to tell whatever it is we're calling. These are the pins we're going to use. The setup is a little bit more verbose than I'd liked. I mean, look, this bit here, for example, is how we blank the display. It's just a little bit verbose. Why isn't there one command here that just says blank the display? Yes, well, our library should give us that. Now, the loop is just a very simple counter. It goes from 0 to 99, and when it hits the number 42 in the middle of that loop, it just flashes it a few times. Yeah, I mean, simple stuff that you might actually want to do in real life. If you're displaying an error code, you might well want to flash it a few times to draw attention to the fact that something's gone wrong with your Arduino project. Look at this particular loop. We can see, it's quite verbose and there's lots of shifts out, which is how we send out serial data from the Arduino, and digital writes and things. And then right down the bottom, I've written this little routine called flash number, which is very repetitive of what we've done before. We've still got the shift outs. We're blanking the digits yet again here. I've already written it once. That should really be a separate function. And this is how it sends out the same data so that it flashes on screen. So all in all, there's a few functions here that could just be made so much easier if we had a library. And not least, there's the actual hardware considerations. Now, hardware considerations means when I designed this little tiny unit, these little tiny LEDs on here, 7-segment LEDs, are in fact common cathode. However, when I bought these larger ones for the purposes of the demo, because I thought, yeah, it'd be much easier to see those big digits rather than my little tiny ones, I discovered, quite by chance, that it was in fact a common anode device, which means the anodes of all the little LEDs on there are all connected together. And you think, does it matter? Well, unfortunately for the code, it does matter, because the bit pattern to illuminate some of those 7-segment displays is the exact opposite on a common anode device compared to a common cathode. So it'd be pretty useful, wouldn't it, if the library could be told, by the way, my display is one of these, common cathode or common anode, do the necessary, whatever that is. And the person invoking that library doesn't even have to know what's going on behind the scenes, just the way we like it. Now, when you write a library, there are two files you need. One's a header file with a .h suffix on the file, and the second one is the .cpp, C++ file, where all your code resides to support the functions you've told the compiler about in your header file. Now, this here that you're looking at is a header file. Now, I've called my library dual-digit_74hc595.h. Just trips off the tongue, doesn't it? Yes, I know. Descriptive, meaningful, and most usefully unique. I suppose I really should have put RSB somewhere in there, just in case somebody else has already written one of these. Anyway, for demo purposes, I think that will do. Now, at the top of your file, yes, pragma once, and include the Arduino header, because we are writing in Arduino speak, C++ after all, and we need to tell the compiler where all that code is. So that's what that line's doing. Fine, and then we're declaring a class called dual-digit, so yeah, exactly the same as the file name. Let's keep it the same and everything in sync, otherwise things get really muddled in your own head. Now, okay, time to address the elephant in the room. There it is, that big fat elephant, yes. This is a class, as it says. We are writing object-oriented code now, because C++ is object-oriented, isn't it? That's the whole point about C++ versus C. Well, okay, one of the points anyway. So let's not shy away from the fact that we are now writing a class which is a blueprint for an object. And we'll discuss what an object is and how it comes out of a class when we run our little simple sketch, our demo sketch, which you can see hovering up here, ready to go. So let's have a look at the class. And we said in our previous bit of the video, there are some things we want this class to do for it to be useful in controlling that two-digit display. So let's open this up and have a look. Now, immediately you'll see that there's the word public here after that class, because these are all the functions that your sketch, this one up here, has access to. Okay, anything listed under public down here, yes, your sketch has got access to, and you can call and do whatever it is you need to do. So in here we have our wish list of functions, as it were. There's no actual code in here, remember. These are just declarations of what the function will look like. So we'll just skip the first two and come back to those in a minute. What we've got is an update char function. We have an update value function, send out function, and flash digits function. Great, that's it. That's all that the public functions are for our sketch to consume. Oh, one more, blank digits. Yes, well, blank digits is very useful when we're flashing the digits to call attention to a particular value. These, I think, we can understand as just being functions that do stuff, yeah, in much the same way as what that Arduino sketch did previously and written in standard C++ Arduino speak. But what about these first two then? Okay, well, so we've got the name of the class here under public, and we even have a parameter put in here. Now you need this because this is what's known as the constructor. When you have described what your class looks like in this blueprint, that you need to tell the compiler, oi compiler, I would like one of these please as an object. I want you to instantiate that as a real thing now in memory. So the compiler goes, okay, I'll call that particular function and I'll create you in memory however many bytes it takes to manage this object. You've told me some functions that it needs here already, and in a minute we'll have a look at some of the internal workings of that class. So the compiler does the work for you, and it's nothing to shy away from. The parameter that we put in here is optional. I've decided I'm going to put this particular parameter in here because, well, I wanted to demo that that's how we can do it. But similarly, this function here called begin, which by convention only is a function that most developers, when they're writing classes, include to initialize the object. To make things easy for the programmer, the developer, that's you, to use it. because we need to pass in the data pin, the clock pin and the latch pin, and what better way is it to do it here? Sorry, what's that? We could have done it in the constructor. Yes, we could have done it in the constructor. We could have added these 3 parameters up here as part of this instantiation function. Or we could have moved this one, of course, down into the begin. But there are 2 ways of doing it. 6 of one, half a dozen of the other. You can make your own mind up. But most developers do put a begin in, which you include then in your sketch in the startup to say, this is what I want you to do with that object. Or here are the pins, as we're doing here, to let you know how to control it in future. So that little ball of memory now floating about that describes your object, and the compiler keeps track of that, it says, okay, the values that you're going to pass into me, I'll keep as part of this object and keep it all as one contiguous thing. This send out. Well, remember, when we're updating digits, we might not actually want them to be displayed just yet, especially when we're updating an individual character like this. We might say, put a 4 in the leftmost digit and a 2 in the rightmost digit, but you can't actually display the value straight away. You want to say, well, first let's update those digits, then display it. Yeah? Okay, and remember, there's really, despite what I'm saying here, there's only one way of updating those digits, and it's one at a time. The least significant first, the rightmost, and the most significant, the leftmost, second. It's the only way of doing it. So although we've got a function here called update value, have a guess how it might do that. Okay, so that's all the public stuff, and all this is exposed to your sketch. You can call these. Fine. What's the opposite of public then, do you think? So the opposite of public is private. Anything that goes in private means it's purely for the workings of this class, not to be exposed to the sketch that's calling it. This is for the internal workings only, so within my little library code here, I've got a buffer, a 2-byte buffer. I'm remembering the data, clock and latch pins that you told me about, so we don't lose those. And here, I'm actually remembering the type of display you've told me you've got, whether it's a common anode display or a common cathode display, because the bit patterns are different for each. They are, in fact, the inverse of one another. But who wants to be concerned with all that? You just want to say, I've got a display, it's a common anode, and that's it really. Yeah, here are the 3 pins that I'm using, get on and do it. Great, that's what a library is there for. Though the digits, the binary digits that previously we held in a different file are now in here as a private array. So this is no longer visible to the calling sketch, because the calling sketch should have no use for that at all. It's just saying display a value, get on with it. Cool. Finally, and not used particularly very much, protected, which means it can be used within this class and any class that extends this class, but we're not even going down that road. I'll put it in here for completeness, but it's unlikely that you'd ever put that in. Just don't put it in future, just remove it. Okay, remember, this is a demo. So this is the CPP file, and the very first thing it does is, of course, include the Arduino framework, because we need that here. You probably won't if you're writing this in the Arduino IDE. It assumes you're using Arduino. Then we have to include the header that we've previously declared up here to tie the thing together, to say the functions I'm writing here are for that header over there. Okay, and any other libraries you might need. Or I'm using the string library here, but I could equally be using the wire library, for example, or a crystal 7-segment display library or whatever. As it happens, I only need that one. So here are all the functions basically copied and pasted from the Arduino sketch that we saw right at the beginning of this video, put in here, tidied up a little bit, but basically the same. Let's just have a look at one to see what it looks like. So here we have the update char function. Now remember, every function that you have for your class must begin with the class name and the scope resolution operator, which is those 2 colons there. So it's class, : name of function, then the compiler knows, this is part of that class and not just some random function you've declared somewhere to be used in some other manner. Here are the parameters that we're having to pass into here, mandatory parameters. So this update char, which is really update digit, maybe it's a bad name, maybe I'll change that in the future. We're saying this is my character position, whether it's 0 or 1. This is the value I want you to put into that one, and this is whether or not I want you to include the decimal point. So there's a bit of validation here just to make sure that we haven't gone silly and said update the 48th character when they've only got 2, and also we haven't supplied a value like 3896 when obviously the single digit can only contain between 0 and 9 or 0 and 15 if it's hexadecimal. And then if it's past this little bit of validation, which makes up the huge majority of this bit of code here, we put it into our buffer at the character position, with or without the decimal point. Fine, and then it returns the value 0, meaning everything's okay. Otherwise you get some kind of error returned because we're passing back an integer value. So you can check to see whether it worked or not. You don't have to check, you can if you want. So that's just one of the functions that we've got here. The rest call this a lot of times. For example, the update values that I mentioned, how do you think it works? Well, look what it's doing. It's figuring out from the value that's passed into it what the tens are, the leftmost digit, what the units are, the rightmost digit, and then updating the char 0 and 1 with those values and with or without the decimal point. Yeah, so we're already leveraging the value of this class by calling its own functions to support other functions. Cool. Now, there is one particular function we need to take care of. This is the constructor that we mentioned previously. So this is the constructor where it's the class name, the scope resolution operator there, and the name of the class again. And we're saying this is the type of LED that I'm using. Fine, and then we're creating a little memory buffer, 2 bytes, that's all it is, because we've only got left and right digit, 2 digits, and we're remembering the LED type. Is it common anode or common cathode? All right. Let's not dwell too much on exactly what this is doing because it's very specific to that bit of hardware, isn't it? But this constructor could in fact be empty. You might not want to put anything in there. Perhaps a debugging message as you're constructing it initially to say, I've called the constructor so you can read it, but apart from that, you might not want anything to go in there. And finally, the begin statement that I said, look, we're just remembering the pins, setting the pins to output mode because I know they've got to be, and then it plays around a little bit with the array, inverting those bits depending on whether it's a common anode or a common cathode type display. It just reads them and rewrites them back in the opposite way. Okay, a little bit specific to this hardware though. Oh, and finally, it clears the output here by, once again, leveraging the value of this class by calling one of its own routines called sendout. Cool. I mean, there's not a huge amount in this class, and to be quite honest, once you've written this code and you can build it up, this is what I did. I built it up one function at a time. For example, I did not have flash digits and I did not have blank digits in it initially, but it became blindingly obvious in my sketch that I needed that function because I was writing all this huge amount of code multiple times. I thought this cannot be right. Write it once. Yeah, do not repeat yourself. The dry principle. Otherwise, you're just going to, well, it's inefficient, it looks messy, and you're bound to miss bits if you ever have to go back and change it. Cool. So that is effectively the library. How do we invoke all that then? Right, so this is my demo sketch to show the power of that library. We have to say, yes, we're running Arduino speak here. Here's my library that I'd like, please. Where have I put my library, you say? Well, initially, you can put those two files, the header file and the CPP file, in the same folder where your sketch is, just for playing about while you're developing it. Eventually though, you'll want to create its own folder in your libraries folder, normally a subfolder of your sketches, and put both of them in there. Then you can include that library in any of your sketches. Yeah. Right, so we still have to declare the pins, of course, that we use then to pass into our library. This is where we instantiate that particular object. This is where the compiler says, oh, I've seen your blueprint of the class. You want an actual version of that now, constructed in memory for you, and that's exactly what it does at that point. I've forward declared these two functions that we're going to use as part of the demo. Then we have our setup that is now remarkably small. Apart from the two serial begin and print line statements, we just say dual digit dot begin data pin, clock pin, latch pin. Marvelous. So how does it know about this dual digit? Well, because we've instantiated it here and we've decided to call it dual digit. At that point you could have called it anything, Fred, Ralph, whatever, but make it meaningful. Don't make it too long, because you've got to continually write that in your code because you're referring to it. Now the loop, I've got two examples in here. Example 1 goes through a counter of all digits from 0 to FF. It then displays 42 on individual characters. There we have the 4, there we have the 2, and we send out the value manually. And then we flash the current value. Whatever the current value is out there, flash it. How does the library know what the current value is? Well, remember, it's storing in its little memory buffer now what the last value was. Yes, it becomes sort of semi-intelligent, doesn't it? You don't have to keep telling it what the current value is. You don't have to track that value. The library does it for you. And the second example here is where it displays all the values backwards this time in hexadecimal, but as a value, not a character. So this time it says just display the value 255, 254, 253, and the library goes away and works out exactly what you need, as you saw when we had a look at it. And finally it flashes the digits again. And these are the two little functions here that we're calling. So let's have a look at the all values to see how simple it is. There it is. Look, we're counting backwards from 255. We're saying update the value with the current count. If the remainder is 4, when we divide by 10, put the decimal point out or not. Simple as that, just to prove that it works. And then we send out that value, because remember, at this point here, all we've done is updated the value within the library's buffer, not sent anything out yet. And then we go, okay, I'm ready for you to display that value now. And off it goes and sends it out. Little delay so we can actually see what's happening, otherwise it whizzes through in a split second. You never see anything. So that's all values, and all digits, the one above it, is similar, except we update each individual character one at a time with the outer and inner loop. Okay, if I bring back the desktop, there it is, still running the old Arduino sketch. Let's upload this one and make sure it works, shall we? Right, compiling, uploading. Right, uploaded, there we go. Right, so it's now running. As you can see, it's starting to display hexadecimal values now after 9, A, B, C, D, E, F. Pretty quick, okay. When it gets to the hexadecimal values on the left-hand digit, it becomes much more obvious. And when it's finished counting up all this to 255 FF, you'll see that it will display 42 a number of times. Flash it. I think I've said flash it 5 times, but at least this time I can say any number of times, and it's more to do with the length of the flash rather than the delay between the flash. Much more user friendly. Here we go. Watch this. There we are. Marvelous. So that means now in my future sketches I can import this library just by saying include library name. Don't have to do very much at all apart from tell it which 3 GPIO pins I'm using to control that actual piece of hardware. The end. From then on I just say dual digit display 33, 42, 69, F4. Yeah, it doesn't matter. It's all abstracted away, and that library will stay like that now until I want to expand its functionality in some possible way. So if you want to have some comments down below, you've got any questions, I'm not quite sure of that, but you're going to have to download the code from the GitHub. Dead easy. It comes down as a zipped package. You just unzip it and have a look at the code. It is very simple. Yes, it does pertain to this particular piece of hardware, but it's a simple piece of hardware. You don't have to write it for that hardware, of course. Just display stuff in the serial monitor if you want to just create a little tiny library just to prove that it works. Yeah, so comments, questions, queries, whatever down below. If you thought, oh, this was mildly amusing and I actually learned something, do give it a like up there so I get the old yay.
Hey!
Yes, that one. And remember, if you like these videos, subscribe and hit the bell, otherwise you won't hear from me again. Subscribe and bell. Great stuff. And I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.